10D, we're mainly focusing on the arc length and the perimeter of sectors. So this is the learning aim. Hopefully we will learn to find the arc length and the perimeter of sectors, and by the end of this video you can find the following. Okay, so first off we just need to talk about features of a sector. Okay, um, so if you have a look here, look at my little diagram over here. As you can see, it sort of outlines a circle, but you'll notice that some parts of it are dotted line. What that means is that the circle is not really there. It like technically doesn't exist. So what in reality what this sector would look like is actually like this. It looks something like that, okay? So you can think of it like a pizza slice. It's a pizza slice and it just depends on how big or small it will be. And what determines that is what we'll talk about soon. So you have L here. L is the arc length, and it is highlighted in blue here, as you can see. I'll just make this look a bit neater. So this section here highlighted in blue, and as you can see, it's just this solid blue line right here. This is called the arc length. It's basically just a portion of the perimeter of the circle. Obviously, we know what R is. R is just a radius. So we know R is just a radius right there. So we got this length here, these two lengths. And then finally, we have A. A is just the angle, okay? The number of degrees in the angle at the center of a circle. So it's the degrees right there, okay? Now, the formula that you will typically be using is this very first one right here. You will mainly be using this very first one. I've only given the second one just in case that questions may give you the diameter instead, but you're not going to use it a lot. You'll mainly be using this first one here, okay? So the formula here is L equals A over 360 times 2 pi r. Now, as we mentioned before, this here is the angle. This is your radius. And this is what we're finding, okay? Just like so. Now, let's go through some examples here. Find the length of these arcs for the given angles corrected to decimal places. So I'm just going to highlight some keywords real first. Corrected to decimal places. Find the length of these arcs right here, okay? So what we're trying to do is we're actually trying to find this section here in light blue. So I'll do it for both of them right now so you can see. We're trying to find how long this sections are. Now what we're given here is this 10 centimeters. So 10 centimeters here, this is actually your radius right there. Because if you go based off my diagram, the length there is the radius given. So we know that the radius just equals to 10 centimeters. Now over here in green, this is your angle. So we know A is equal to 50. Now all we're going to do is we're just going to apply this formula right here. I will write this formula just on the top corner. So L equals A over 360 times 2 pi r. So let's just go do it. So I like to write out what I've been given. So we know A equals 50 degrees, R equals 10 centimeters. Now we just apply this formula here. So L equals A over 360 times 2 pi r. Now we're going to substitute the value of A and R into our formula here. So this would just be 50 over 360 times 2 pi. And what I do here is I put this in brackets here. I'm going to put the radius, the number 4 here, in brackets. The next step is to use your calculator. Hopefully you all can see that. So I was going to type it out in my calculator. So press this button here, highlight it in red. This will give it to you in fraction form. And now you just type in whatever it is that you need to type in. So 50 over 360. So to move down from here, press the down on the D-pad over 360. Now to get out of this fraction, you want to press the right button. A lot of people make the mistake of just leaving it like this and typing 2 pi and then they'll do this stuff in. This is absolutely wrong. Do not do it, okay? What you want is to get out of the fraction and type in times 2 pi bracket 4 here, okay? If you just type this in, it'll just give you an answer. Now the question here is saying it wants it to correct to 2 decimal places, so make sure you press the funny button, this double arrow button here. This changes it into a decimal. So let's just round it off. So 3.490. So this just equals to 3.490. I'll just draw what button I pressed. But because we're rounding to 2, the 0 here tells me that I need to round down. So my 9 just stays the same. So I can just write my final answer as 3.49 centimeters. And that's it. Move on to the next one. So I have A equals to 230 degrees. My radius is 2 millimeters. Now just apply the formula. A over 360 times 2 pi r. So just substitute the values in. So 230 out of 360 times 2 pi bracket, my radius is 2. So just type this in the calculator. Now, so I'm just going to go 230 over 360 times 2 pi bracket 2, like so. This will give it like this. Press the double arrow button. That will give me my response. Okay. So I'll just say, I'll just do 8.028. Okay. So if we round this to 2 decimal places, it'll be 8.03 millimeters. So that means the length of that highlighted blue is 8.03 millimeters. Okay. Give this a go. You just apply what it is that I've shown you in the example here. So give it a quick go. Okay. I'm just going to pause this. I'll answer it and then I'll just show you the solutions. Alright, so these are the solutions here. Just double check what you've done is similar to what I have done. If you have made any mistakes, just see where you made the mistake and just correct it and try to figure out where you went wrong. The next thing we're going to learn is the perimeter of a sector. Okay, so this formula here is very important. So I'm going to ask people to copy this down. So what we did earlier was we just found how long L is. That's what we did previously. We just found how long L was before. Now we need to find the length of this whole thing, okay? So this will be highlighted in yellow. So what you're going to do is you're going to add all of this up, pretty much. You're going to add all this up, and you're going to find what this whole distance is. As you have noticed, based on our formula here, this section is pretty much what we did earlier. We're just finding what L is. And at the end, we just plus 2r. So in another sense, you can write P equals L plus 2r. That's another way of doing this, okay? Now, some common sectors that you'll worry about is the quadrant. This is the formula that you will be given. If you're wondering how this makes sense, It's because a quadrant here is 90 degrees. So if I were to apply the formula, it's 90 out of 360 times 2 pi r plus 2r. If you type this fraction here, in your calculator, I'll just make this a little bit smaller. If you type this in your calculator, 90 over 360, this just gives you 1/4. So it's just a quicker way of typing this out. And it's just easier that way, okay? So you're just using this same formula, but it's just simplified a bit further. The next thing you'll deal with is semicircles. So you need to learn all this. Same thing as earlier. I'll probably do this in blue. Same thing here. Half circle. This angle here is 180 degrees. And we have gone through this, I believe. If not, just double check. And this will just be written as 180 over 360 times 2 pi r plus 2r. The same thing as 1/2 times 2 pi r plus 2r here. So over here, 180 over 360. Let's just type that in our calculator. 180 out of 360 gives you 1/2. So there we go. So over here, find the perimeter of each of these sectors, correct to 1 decimal place. I'm just going to do this the original way. I'm not going to bother doing the shortcut way. I'm just going to show you how this would work in practicality. So we know the angle here is 90 degrees. We know the radius is 3 meters. So just apply our formula. Plus 2r. And we know a is 90, so we go 90 out of 360 times 2 pi. Now in brackets here, I'm going to do this, and then 2 brackets 3 again. The reason why I do brackets is because if I did this without brackets, so say for example, if I typed in 90 out of 360 times 2 pi 3 plus 2, 3, as you can see, if you were to look at this number, this reads as 23. Reads as 23. That's not what we want. We want to not do this, okay? So that's why we put the brackets in to indicate, hey, this just actually means 2 times 3. So if you were to type this out on the calculator, 90 out of 360 times 2 pi 3 plus 2 bracket 3 like that. Just type this in exactly. It'll give you the answer you need. So in this case, it'll be 10 point. Let's have a look here. It says here correct to 1 decimal place. So 10.71. But because it's 1 decimal place, we only ended up at 10.7. 10.7 meters. That means the distance between the distance in this light blue, the whole distance here equals to 10.7. Okay. The same thing for this one, for the second one. So A equals 180. So in this case, this is pretty special, right? So what we're given here is actually the diameter. This is the diameter here. But the formula that I gave you earlier just worked in radius. Now, if you remember, the special relationship between radius and diameter is that diameter, I'll do this in a different color pen. Diameter is double the size of radius. So if I want to go from diameter to radius, I need to half it, so I just go 5 divided by 2, which equals to 2.5. Now that we have the radius, we can just plug and play our formula. So it'll be A equals, no, not A equals, what am I doing? Times 2 pi r plus 2r. Let's substitute the numbers in. 2.5 plus 2 bracket 2.5. Brackets. So if you just type this in exactly as intended, $12.85 to 12.9 kilometers. So perimeter equals to 12.9 kilometers. That's it. So again, just give it a go. I'll be back soon. Alright, so these are the solutions here. Give it a, hopefully they align with what I have done. Okay, so we'll be moving on. So now you got composite shapes here. So composite shapes are with like these funny sectors. So what you're trying to find, same thing. You're trying to find the outside highlighted in blue. But it's a bit tricky because we now need to find what green is. So just based off my diagram alone, I can see that this is 10 centimeters. And over here, this red dotted line is also 5 centimeters because like a composite shape is just two simple shapes combined together. Okay. So because the width of the rectangle is 5 centimeters, that means that red dotted line is 5 centimeters. Now, if you were to separate the diagrams, if that's 5 centimeters, this is the radius, so that means the bottom section here is also 5 centimeters. So what I like to do is I like to indicate which one's which. So this is 5 centimeters here, like that. Now we need to find what the green is. So green, oops. So L equals A over 360 times 2 pi r. This will just be 90 degrees. The radius in this case is 5. So type this in exactly on your calculator. 7.85. What is this? 7.9. So now that we know that the green is equal to 7.9 centimeters, we just need to add everything up. So it equals to 10 plus 5 plus 10 plus 5 plus 7.9. And if you were to add all this up, you end up with 37.9 centimeters. That's a distance of blue. These are the questions you got to do. Make sure you complete it all. Take care.